Okay guys, so in this lesson we're going to learn how to solve systems of equations using substitution and elimination. So I'm just giving you a heads up that I don't use substitution that much, but we're going to go through how to do it, and we're going to use elimination a lot more than substitution. Okay, so the first section. So methods that we can use for systems of equations include substitution, elimination, graphing. So when we have a graph, the solution to the systems of equations is the intersection point. Cramer's rule, we don't use that much. That uses determinants and then matrices. So I'm going to show you how to solve these equations using the calculator and matrices in the next lessons. Okay, so first one, we're going to solve using substitution. Now, what I would do is, whenever I'm looking at this, whatever variables by itself, like y is just by itself, that's when I would maybe use substitution. So what I'm going to do is I'm going to solve for y up here. So I get y is equal to 5 minus 2x. Okay, in the first equation. Now I'm going to take that and I'm going to substitute it in for y into the bottom equation. Now we're going to make sure that we distribute. Okay, so we get negative 4, negative 12, that's negative 16. And I'm going to move this 30 over here. Okay, so 12 minus 30 is a negative 18. Something's not, is that right? Okay, so I'm going to solve for x. And I get 9/8 whenever I reduce the fraction. Okay, so once I find my x value, I'm going to plug into over here to solve for y. So y is equal to 5 minus 2 times 9/8. Okay, so we get y is equal to 5 minus, let's see, that will cancel 9/4. So around the world, 4 times 5 is 20 minus 9, so it's 11/4. Okay? So I get the point 9/8 and 11/4. Let me just double check this. Those numbers are kind of weird to start off with. Yeah, that's right. Okay, so don't freak out if you get fractions. Not all of the things are going to be whole numbers, and I actually tried to pick problems that didn't involve whole numbers a lot, so you get used to dealing with fractions. Okay, the next one. I don't know if y'all did this type of question in Algebra 2, but so it's x plus y squared is equal to 5 and 2x plus y is equal to 4. So when we have a y squared, I'm going to, same strategy as what we did before, is I'm going to solve for x. So we get 5 minus y squared is equal to x. And I'm going to take that and I'm going to plug it in down here. And I'm going to have to distribute. And distribute that 2 out. So I get 10 minus 2y squared plus y is equal to 4. Now, anytime we have y squared and that sort of thing, we're going to have to probably factor. So I'm going to move everything over to the right side, make everything, so we get a positive y squared term. Okay, and then 4 minus 10 is a negative 6. Now you're going to have to use PSF on this or use your box method. So it should factor to 2y and y. Let's see. 2 and 3. So negative 2 and plus 3 like that. So I get y is equal to negative 3 halves and y is equal to 2. If you need to do your box method out to the side, feel free to do that. Now, we're going to take these values and we're going to plug it in for x now. So we'll have two answers, two solutions. Negative 3 halves squared is 9 fourths. So 5 minus 9 fourths is 11 fourths. If I plug in a 2, 2 squared is 4. 5 minus 4 is 1. So they're going to intersect at the point 11 fourths, negative 3 halves, and the point 1, 2. Like that. Okay, so that's a little more difficult question. We hadn't seen one like that. Probably your whole entire life. So when you have a squared or a cubed or something like that, you're going to solve for whatever variable's by itself. So the x is by itself. It's not raised to a power or anything like that. So that makes your substitution easier. Okay, now we're going to do elimination. On elimination, it doesn't matter which variable you eliminate. A lot of times I like to eliminate y's first, but it doesn't matter. Or I just choose what has the opposite signs already. So in this case, I'm going to, so you have to have the same thing on top and bottom, and they have to be equal and opposite signs for it to cancel. So I'm going to multiply the bottom by 2, because I would get a negative 2 here, and those would end up canceling whenever I add down. So we get 2x plus 3y is equal to 1. Negative 2x plus 2y is equal to a negative 6. We're going to add down. We get 5y is equal to a negative 5. So y comes out to be a negative 1. Now, it doesn't matter which equation you plug into to solve for the other variable. So we get 2x plus 3 times a negative 1 is equal to 1. So 2x minus 3 is equal to 1. Add the 3. So we get x is equal to 2. So it's going to intersect at the point 2, negative 1. Next question. So we can eliminate x or y. It really doesn't matter. I'm probably going to eliminate, let's go with y on this one. So you got a 2y here. I have to multiply the top equation by negative 2y. So negative 4x minus 2y is equal to a negative 10. And 4x plus 2y is equal to 8. Okay, so I noticed that these are going to cancel, so I get 0 is equal to a negative 2. Now, 0 is equal to a negative 2 is not a true statement. Okay, so this is going to be no solution. So when we get no solution, they're going to actually be parallel lines that never intersect. Okay, so that's the definition of a parallel line, is they have parallel slopes and they never intersect one another. Okay, next one. I'm going to eliminate, let's say, x. So I have a negative 6x on bottom. I need to get a positive 6x on top, so I'm going to multiply the whole top by 3. So we get 6x plus 3y is equal to 12. Negative 6x minus 3y is equal to negative 12. Now, if you see, this is going to cancel and everything's going to cancel. So we get 0 is equal to 0. So this is a true statement. So it's all real numbers. So what happens is those two lines are actually on top of each other. So they intersect at every single point. Okay, now onto the back. Now you might have not done a 3x3 system of 3 equations in the past, especially by hand. But I want to make sure I go through it for, say, a college algebra class or some other class you take in the future. So in this type of example, we're going to pick a variable to eliminate. So when you have 3 variables involved in 3 equations, I like to eliminate z first, okay? So what you do is you group the first 2 equations together. So x plus y minus z is equal to a negative 1. And I group the second equation. Okay, So I have to multiply the top by 2 to get rid of z. So I'm left with 2x plus 2y minus 2z is equal to a negative 2. And then I have 4x minus 3y plus 2z is equal to 16. Add down. So that's my first equation. Now I'm going to do it again. Now I'm going to deal with the second and third equation. Now you still have to eliminate the same variable that you did as the previous one. Okay, so if I'm eliminating z, the least common LCM, least common multiple between 2 and 3 is 6. So I'm going to multiply the top by 3. This already has the negative, so I'm going to multiply the bottom by 2. So we get 12x minus 9y plus 6z is equal to 48. We get 4x minus 4y minus 6z is equal to 10. And our z's will cancel, so we left with 8x minus 13y is equal to 58. Okay, now from there I have two equations, two unknowns, so I can eliminate once again. Okay, so I'm going to line those two. I'm just going to line it up right below this one for the sake of room. So I take that. Okay, what I would do in this case is, I'm trying to deal with the least amount of numbers as possible. Okay, I'm going to multiply the bottom equation, so I have a negative 13 on top. I'm going to multiply the bottom one by a negative 13 to get a positive 13y. Okay, so we get 8x minus 13y is equal to 58. And I'm going to use my calculator. 13 times 6 is 78. So negative 78x plus 13y is equal to 13 and 14 is negative 182. Okay, so those will end up canceling. So 8 minus 78 is negative 70x. 58 minus 182 is a negative 124. Hold on, is everything right there? Let me make sure this is right. Hold up. I didn't work these problems before, so they could be kind of goofy. Or I could have been working way too many problems and can't see straight at this point in time and messed up on something stupid. Yeah, something's not right. Hold up. It should be 2. Oh, I see what I did. I subtracted right here. This should be 16x. I think all the 3x3s, I got nice answers on it. Negative 62x. 124 divided by 62 is 2. Yeah. Little mistakes will get you. Okay, so I get x is equal to 2. Now, once I find my my x, I'm going to solve for y over here. So y comes out to be, so 12, negative 2, it should come out to be 2, negative 2. Yeah, negative 2. Okay, so I'm taking this and I'm plugging it in right here. So 6 times 2 is 12. 14 minus 12 is 2 divided by negative 1. Now, we're going to go find z. So in order to find z, let's plug into the top equation. You can plug into any of those equations. So your x is 2, your y is -2, z is what we're looking for, so it's 0. So negative z is equal to a -1, so z comes out to be 1. Okay? So these intersect at the point 2, -2, and 1. Now those 3x3s take you a little bit of time, so just be careful. I mean, as good as I am at math, I mess up on stuff every now and then, so it's a lot of numbers to keep track of. So you have a lot of practice problems over that, so make sure you take your time. Okay, a movie theater sells a ticket for $8 each, with senior citizens receiving a $2 discount. So if they receive a $2 discount, that means that their ticket price is $6. Okay, so we're gonna set up a system of equations. So we'll call this 8x plus 6y is equal to, and it took in $35.80 worth of revenue. Okay, so that's how much they made for the night. They took in before they have to pay all their costs. Okay, now if the total ticket sales were 525, so x plus y is equal to 525, we want to figure out how many of each type of ticket were sold. So we're going to use elimination. It doesn't matter which variable you decide to eliminate. Okay, I'm going to eliminate y. So we need a -6 on the bottom. So we got 8x plus 6y is equal to 3580. And this type of question shows up on SAT so much that you need to make sure you know how to do this quickly. Okay, and okay, so this comes out to be -3150. I don't expect you to be able to multiply that number in your head. So we get 2x is equal to 3580 minus 3150 is 430. So what, 215 is how many tickets were for x. Now to find y, we're just going to do x plus y is equal to 525. So 525 minus 215. Your senior citizen tickets is 310. Okay. Next one. It says the length of fence required to enclose a rectangular field is 3,000 meters. So that's your perimeter. So perimeter is 2L plus 2W, and that's equal to 3,000 meters. Okay. And it says that the difference between the length and the width, so L minus W, is 50. Okay. Now, we want to eliminate a variable. I'm going to eliminate the W, the width. So I need a -2 on the bottom, so I'll multiply by 2. So we get 2L plus 2W is equal to 3,000. Okay, so it's going to cancel, so we get 4L is equal to 3,100. 3,100 divided by 4 is 775 feet. Now, if I want to solve for W, I just plug into one of those two equations right here. So I'm going to say 775 minus W is equal to 50. Okay, so that means that W comes out to be 725 feet. Okay, and that's how we do a perimeter problem. You could also work it using substitution. That's okay with me. I'm not opposed to substitution, I just don't like to use it. A recently retired couple needs $12,000 per year to supplement their Social Security. They have decided to invest $150,000 to obtain that additional income. They have decided on 2 investment options: AA bonds, which yield 10% per year, and a bank certificate that yields 5% per year. How much should be invested in each to make exactly $12,000 per year? That's pretty much dumbing down the language of this problem. Okay, so we're going to take 0.10x plus 0.05 y is equal to 12,000. Okay, so that's their simple investments. Now, their total investments, x plus y, is 150,000. Okay, so when we're going to do this, it doesn't matter what you eliminate. I'm going to eliminate y. Okay, so I'm going to multiply the bottom by negative 0.05. So 0.10x plus 0.05y is equal to $12,000. Okay, 150,000 times negative 0.05 is minus 7,500. Okay, so 12,000 minus 7,500 is 4,500 times 20 is 90,000. So x is equal to $90,000. Now, if they have $150,000 total, that means y has to be 60,000. Okay, and you can get that by plugging into this equation right here. I'm going to show you some methods to do this in the calculator very quickly. That way you're not wasting time on your SAT or ACT or any sort of other time test that you're able to use a calculator on. But you need to know how to do this stuff by hand in case there's smaller numbers that don't involve a lot of work. Okay, so hopefully you got something from this. This has been Solving Systems of Equations review. Thanks. Have a good night.